Hi all, this is Dr. Brad, and I'm just going to answer your question real quick. So you were curious on how things like fossils or animals get their names. So this is something that's actually kind of tricky question, but we can talk about that. So the way we name animals and plants is kind of going back to the ideas of a scientist from the 1700s, Carl Linnaeus. And he actually came up with a system for naming organisms at kind of a broad level and at a very specific level. So you can think of it as like different levels in terms of giving things names, right? Like we are within the genus Homo, that's the genus for people, and then sapiens, that's our species. We're also within primates, as well as mammals, within vertebrates, within animals, right? So we have this tiered level of how we name certain groups of organisms, okay? Now let's talk about what that word species means, because this is actually sort of tricky and a really hard scientific question. So what do we mean by a species? Well, there isn't a great definition of what we mean. Now, in biology, in the modern day world, what it means is a group, a population of organisms, a group of animals or plants that can produce offspring. So they can have babies that are then able to have babies themselves. So in this case, you could think of it as like, okay, two horses can have a foal that then can produce the grandchildren of that original set of horses. This is different from like mules, which are the offspring of donkeys and horses, right? So that's what we mean. We mean if they can produce this viable lineage, this viable family structure through time, they're part of the same species. And this is really hard in biology because this is a tough thing to recognize, right? And a hard thing because it takes time, right? To see like multiple generations going through. And in the fossil records, it's even harder because they're all extinct or they lived a long time ago. So we can't use that way of telling one organism versus another. So what we do is we give it a really sciencey name for this really simplistic idea, which is the morphologic species concept. And all it means, morphology means the study of shape. We basically ask if fossils look the same. So what you do is if you found a brand new type of fossil and you didn't know what it is, well, you go into the literature, previous studies, and compare it to those organisms and ask, does this look different than these other organisms from the past, or does it look the same, right? And that way we can try and tell if something's different from what we have. Now, how much different does it need to be a different species? Hard to say, right? And if you look at different scientists, they actually use different amounts of difference in defining what's a fossil species. So some people name a lot of species on really tiny differences, and other people lump very different looking animals together as part of the same species. But there's ultimately no way we can tell from the fossil record because they ultimately look the same. Okay, so let's say we find a new species and we go to the literature or go visit museums and piece together everything that looks sort of similar to it, and this organism looks different. Well, what do you then do? Well, you have to describe the organism, right? So the first task is to sit down and very systematically talk about all the features of the organism, and then talk about how those features are similar to animals that have been reported before, that other people have been found and talked about, and how it's different, right? And if it's sufficiently different that other scientists agree with you, then you can make a new animal name. You can name something brand new. And there's rules behind this as well, right? For the level of organism, right? It's unlikely we're going to find a new kingdom of organisms, right? Like that's on the level of plants or animals. It's unlikely we'll find a new phylum. That'd be like vertebrates for us, or mollusks for snails, or arthropods for bugs, right? Those are all just the sciencey words for things. But normally what we find are new genera, right? Like Homo sapiens, Homo would be us, or species, right? So new species would be something that we know is in nature because we see their close relatives, but we don't see that animal ever before. So what you'd then do is find this animal, say it's different, and show that it has some features that are different or some kind of shapes that are a little bit different. And then you describe it and talk about its difference and who it's related to. And then you can give it a name, right? So pretty much what we use is either Greek or Latin for most parts. There's some animals I'll mention in a second that can differ from that, but we usually use the Latin or Greek and then come up with a name that documents what it is. So again, you can see these names going on. Things like dinosaurs often have that saurus for the end of the name. Brontosaur or Tyrannosaur or Brachiosaur. And ultimately, they're just, saurus means lizard. So that's all these names mean. So Brachiosaurus just means arm lizard, right? Silly, but that's kind of what it is. Or the sciencey name for snails is gastropod. That just means stomach foot. Okay, so if you were taking like most zoology classes, the study of animals, in Greek, it would be so bizarre because all these names would just mean like, wait, what's the difference between an arm foot and an arm lizard? Well, those are very different organisms, but again, they have very similar names. Okay, so we use that Latin or Greek. Occasionally they use other languages, which is actually really pleasant because then you can kind of diversify the names. And often what paleontologists will do, especially if they find it on indigenous people's land, is that they'll give that option to the indigenous people. One of the famous examples is this animal called Tiktaalik, which automatically you can hear sounds very different in terms of the structure of the name. But in this case, they found it in northern Canada on indigenous land, and they went to one of the local tribes and asked, hey, here's this animal. Here's the significance of this organism. And do you have any suggestions for names in the local tongue? And then they came up with a couple names of these organisms that are important, right? So they can actually give the name some local importance in terms of the people that have a history in that area. Okay, for the species name, usually the species name is something that's going to be descriptive, right? So either it's going to be something about the animal itself, or the location it was found, or the person who found it. You can't name a fossil after yourself. That's like one of those rules, right? If I found it, my last name's Deline, I can't call it, something Acrinus delinei, because you can't name it after yourself, but you can name it after someone else. So let's give an example. All right. Luckily, I've done this a couple times of naming organisms in the fossil record. So what do? You find a fossil, or someone finds a fossil, they bring it to you and say, hey, I think this is new to science. So way back in about a decade ago, I worked on this paper. There's the paper there. Woo, science. And they found this animal called a paracrinoid. What is a paracrinoid? It's a long extinct relative of starfish. So like 450 million year old relative of starfish. And so they found this fossil. Here I can show you a picture of it. There we can see the fossil itself. You can see there's the fossil. And it's beautifully imaged here. My friend took great pictures of it. Here you can see it as it is. And then here you can see it submerged in water, which shows some of the features of fossils as well. Now, so we found this fossil, and what we had is this animal. So we had to identify kind of in a broad sense what it is. And so we could go into the fossil itself and be like, okay, well, I know it's part of this paracrinoid group given on the features, right? Because we study these groups of organisms. And then we could look at the feeding structures. That's what these little like S-shaped things are here and here. And we can see that it has an opening there for the mouth. Weird, right? I love these animals. They're called paracrinoids. They're just weird. Echinoderms, relatives of starfish, do lots of odd things. So this animal here, it turns out, well, there's already a genus of this animal known where it has that exact same structure, and the genus itself was called Bistomia cystis. Bistomio, that means two-mouthed, because it has two feeding grooves that look like little S's, and then two openings into the mouth, into the body itself. Strange. Bistomio, two-stomached cystoid. Essentially, this group of organisms are known as cystoids. So again, we have this animal, Bistomia cystis. Then what we did was we looked at this animal And we could find differences between this and the only other species that's been described before. This one's from Kentucky, the other one was from Oklahoma. This one here has those little star-shaped patterns on the plates. Can see that. The other one didn't, it was nice and smooth. So we know it's a different organism, okay? It's a different species, it has different features across it. And so we documented the differences, what was similar with the other species, and we gave it a name based off of the guy who found it, right? So the amateur collector who did the hard work of going and collecting and discovering this new to science fossil, his name is Rick Schranz. So we named the fossil by Stomi-assisted Schranzeri, right? So we just took his last name, added an I to the end of it to make it sound all sciencey and Latin-y, and that gave us our name itself. So that's kind of the process, right? You find something new, find a new dinosaur, find a new plant. You then have the huge scientific task of finding out everything else that it could be related to and finding out if it's in fact different and then convincing yourself if it's just different enough, and then you can name the animal itself. And again, this is the process that happens every time a new organism is found, and largely the same system going all the way back to the 1700s when dinosaurs were first discovered, right? That first dinosaur that was discovered by Gregory Mantell and his wife actually found it. Well, they found these organisms, they had partial information, they named it Iguanodon, right? And erected the first name for the animal group itself. Iguanodon just means, well, iguana tooth, because they looked at the teeth and thought it looked similar to that. And then ultimately used the name Dinosauria, terrible lizards, simply because then it fits into that whole system of naming it, giving it a group to have some classification for figuring out how things are made. So hopefully that made sense. And feel free to ask me more questions if you'd like. Have a good night.